Let's take a look at this initial value problem. Y double prime plus 4y prime plus 13y equals the sum of these two impulse functions, where I have an impulse at pi and also an impulse at 3 pi. To do this, we'll find the Laplace transform, s squared y of s minus s y of 0 minus y prime of 0. That's the Laplace transform y double prime, plus 4 times s y of s minus y of 0, that's the transform y prime, plus 13y of s. On the right-hand side, the Laplace transform of this delta function is simply e to the minus pi s, and the Laplace transform of this delta function is e to the minus 3 pi s using the table. So simplifying, we get that s squared plus 4s plus 13 times y of s, that's combining this term, and this term, equals, okay, so here I have s times 1, so I'm going to bring that over to the right-hand side, it becomes positive, that's a 0. Also here I have negative 4 y of 0, so that comes over to the side as plus 4, so plus 4 plus e to the minus pi s plus e to the minus 3 pi s. Okay, so dividing, we find that the Laplace transform of the solution is s plus 4 over s plus 2 squared plus 9. So what I've done is completed the square here, plus e to the minus pi s over s plus 2 squared plus 9. Then e to the minus 3 pi s over s plus 2 squared plus 9. All right, we're almost home with this. Let me set this up in the form of a Laplace transform, s over 2, s plus 2, s plus 2 squared plus 9. Then I have plus 2 over s plus 2 squared plus 9, plus e to the minus pi s over s squared plus 2 squared plus 9, plus e to the minus 3 pi s over s plus 2 squared plus 9. And we're almost ready to do the inverse Laplace transform, except it's because this part matches, but this part I need a 3 up here to match the 3 squared that I see here. So s plus 2 over s plus 2 squared plus 9. Then I'm going to put a 3 here, and of course I need to multiply by 2/3 to compensate. S plus 2 squared plus 9. Likewise for these others, I need a 3 in the numerator, and then a 1/3 in front to compensate. 1/3 times 3, e to the minus 3 pi s over s plus 2 squared plus 9. So that is the Laplace transform y of s. Therefore, using the table, y of t is equal to the inverse Laplace transform of the first term is e to the minus 2 times cosine 3t. This next bit, I've got plus 2/3. The inverse Laplace transform of this is e to the minus 2t times sine of 3t. Then for this term, I've got the 1/3 in front. This part matches this part. And so the inverse Laplace transform of this, when I have the e to the minus pi s, will be basically the same thing as this, except t gets replaced by t minus pi. E to the minus 2 minus pi like this, sine of 3 times t minus pi. Then I have to multiply by the step function at pi. Then for the inverse Laplace transform of the last part, it's going to be roughly the same thing as what I have here, except because I have an e to the minus 3 pi s, everywhere I see a t here, I'll replace by t minus 3 pi. So e to the minus 2, t minus 3 pi, sine of 3 times t minus 3 pi, then multiply by the step function at 3 pi. And this can be simplified somewhat with trig identities, but that's basically going to be the answer.